Phase diagram is a graphical representation of heat energy that we supply to a material and the respective temperature variation of that state, that substance, right? So let us consider a material in a solid state, and you keep supplying the heat energy to that material, and you want to study how that its temperature gets affected. So we take heat supplied to the system on x-axis, and we take how much temperature gets affected, temperature rises on y-axis. Assume that we have taken a solid material and we have uh, supplied the heat to that. So for a solid material, when you heat it up, what happens is its temperature increases. It will be increasing. This is in which state? This is in solid state. But somewhere this solid converts into liquid. So until the solid is in a solid state itself, with respect to the proportion of the heat supplied, temperature is also increasing. The graph is a proportionate graph starting from the origin. But somewhere, for example, like ice at 0 degree centigrade converts into water. So during the conversion from ice to water, one thing that you need to understand is temperature, which is called something like melting point here, remains constant. Why the temperature remains constant? Because all the heat energy supplied is used to increase the distance between the molecules so that the solid will become a liquid. There is no extra heat energy available to rise the temperature further. It needs a big energy. So what all the heat supplied is used to increase the distance between the molecules, so the solid will become a liquid. So even though you are supplying the heat, during the change of the state, a material from solid to liquid state, temperature remains constant during that state. For water, that is called something like a melting point. For any material also, you can call the same. So during that change of the state, specific temperature remains constant. So while you can name these things as O, A, B. So during heat supply in solid state, delta T is there. There is an increase in temperature. Basing on the definition of the specific heat of that solid, specific heat is defined as amount of heat required to rise the temperature of unit mass of substance by 1 degree centigrade. Whatever the dq that we have supplied is ms delta T. As m and s are constant, dq is directly proportional to delta T. That's why the graph is a straight line passing through origin. So in this case, we can use a formula dq is actual to ms delta T. But now look at the second case. During change of state, that is between AB, this is in the case of OA. In the case of AB, temperature remains constant. All heat is used to convert the substance from one state to other state. So I can use the definition of latent heat as amount of heat required to convert unit mass of substance from one state to other at a constant temperature. This implies dq can be written like ml. So in the case this A to B, dq is nothing but ml. Be careful. You need to know when we have to use ms delta T and when you have to use ml. During the rise of the temperature, ms delta T. During the change of the state, ml has to be used. Now the solid to liquid conversion was happened, assume like so. Now it is already a liquid, no more a solid state. If you are keep supplying the heat energy, then the liquid temperature again increases. This is in liquid state. Again dq, I can use a formula ms delta d in that state also. Again, at a particular temperature, though you are supplying the heat energy, all the heat is used to convert the liquid into gas, that is to increase the distance between the molecules. Here liquid is becoming gas. So here also the temperature remains constant, delta T equal to 0, like in this case. During this state also, what all the heat that you have supplied at a constant temperature, for water you can call that temperature as a boiling temperature, 100 degrees centigrade for water. All the heat is used to convert the substance from liquid state to gaseous state, that is dq equal to ml. So until then, until the change happened, the temperature remains constant. Now once the liquid conversion is over, liquid to gas conversion is over, now this gas, with respect to the supply of the heat energy, again the temperature also increases. So there are different phases involved. That's why this diagram is called, this graph is called as a phase diagram. So from all this, I want you to understand one simple thing, that whenever there is a change in temperature, substance is in one single state, for dq, then I shall use this formula. Whenever there is a change in state, temperature remains constant, for dq we shall use this formula. These are the two regular formulas that we use in calorimetry and thermodynamics, right? So during that change of the state, temperature remains constant. During the substance is in a single state, in solid, in liquid, and in gas, delta T is not equal to 0. Delta T is there is a increase in temperature. So change of state, during the change of the state, temperature remains constant. That's an important thing that you need to understand. Thank you for watching.